We're recording. All right. Hey, somebody tell me something that piqued your interest yesterday from my class.
Decimal.
Desmos. Okay. Anything else that piqued your interest from my class? The partner test. You like that? That's good stuff. Anything else that piqued your interest? How quick you can factor all day long. Anything else piqued your interest? Yeah. How credit cards work? We're going. That's a whole Friday lesson that we'll do. Hey, what's this coming Friday's lesson? Being how to become a millionaire. Kid you not. Kid you not. I tell you, if this guy who could not count his ears twice to get the same number can get there, you all can. You're like, dude, did he? You have sometimes catch on that I have a lot of sarcasm when I'm talking. Not trying to be sarcastic, but I am. Just because I laugh when old people fall. I mean, there's nothing big bad about that. All right, so we did problem number 1, we did problem number 2, and we talked about it on a factoring perspective, right? But we didn't really factor it because our game is to realize it is really okay to utilize technology, because factoring something by using a trick doesn't always mean you understand the concept. Need one? Okay. I'll tell you, my freshman put it back here. You can keep that one. So my rule on pencils, you can borrow them. You just have to bring them back to me the day you graduate, okay? 29 years I've had one student. Last year, one student at graduation. Here you go, Mr. Sharp. I'm like, nice. So I guess it worked once. But we were talking about factoring these, but we weren't using factoring by the tricks that you had been taught in Algebra 1, Algebra 2, and any other class. And the hard thing is for you as students to kind of fathom about this, the concept of understanding math and logically reasoning through math can really get to a higher level when you utilize the technology to get through the nitty-gritty stuff. It's like we've all been in a class where all of a sudden you have some teacher who's going through something and they go through like this miracle process to get a mathematical problem to work quickly, and you're spending more time going, where did all that come from? And that person's like 17 steps ahead of you. Agree? But you're like stuck on the beginning going, it doesn't mean that you learned it. And it's like, when you have fractions in a problem, most freshmen, they have a fraction in a problem, they skip it. They also skip the ones that have words. You don't want a word problem. I'll do something else. So let's take a look at number 3 on that page in your book. And my eyes aren't as good as they should be. I believe it says 4x squared minus 13x plus 3. Does that seem correct? Cool. Okay. So, yeah, you know what? We could go through the whole factoring mess with this problem. Okay, the way I have taught factoring for many years is I multiply when your lead coefficient is not 1. I multiply the first and the last, and that gives me 12. And then I realize that 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12. They both have to be negative. Which of those combined together would get me negative 13 and get through and break it up? And it's kind of called factor by grouping. It's a trick. It's a trick to do it. It's a trick to make it work. It doesn't show that you have an understanding of what the problem is, but I think because of yesterday, you realized we did 2 of the problems, and both the problems were both squared, and so we got a parabola out of it. So this one is also squared. Is there anything about this problem that would tell you that it's not a parabola if I were to graph it? And the answer hopefully is no. So let's see what we got here. Oh, I want to go to, hey, we're going to our favorite, Desmos, right? And you can always use your computer. You can always use your phone on Desmos, even on tests and quizzes. And tests and quizzes, compare, share, and revise is how all the tests and quizzes are. You want to know what I don't have problems with in this class? You know that there's some students, and I know it's never any of you ever. We have a test today. You have a longer lunch. Then you talk to your friend, hey, was on the test. and then your parents call in. They had a dentist appointment. You know what happens in this class? Because compare, share, and revise. Nobody misses during test quiz days because you get to work out together. When you miss, you got to come working on your own. That kind of stinks. Because collectively together, we're smarter together than we are as an individual. So that's kind of one of the things. So, you know, a little bit of, it's not, you know, uncomfortable group work that we do in my class. It's comfortable group work where you might have somebody who is more listening to what's going on. That doesn't mean that they're just plagiarizing and cheating. That just means that they are going through their thought process to learn it. So what were the two main important features about this graph? Yeah, the x-intercepts, yeah. So now we're going to get to kind of a little situation here that we have 0.25 and we have 3. So 0.25 and 3 are two things that we're worried about. Agreed? Okay, so we're going to be able to factor this, but we just have to have the knowledge of how to factor. Okay, now, you probably recall from Algebra 2 or Algebra 1, maybe geometry, that there does become some that don't factor. And then we have a stupid song for you guys to sing that goes along with the quadratic formula. Remember that x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Remember that one? If not, you didn't have me. So, but again, it's a trick. It's a trick. It's a plug and chug formula, which doesn't necessarily mean that you understand what you're finding. It means that you understand how to plug and chug and you are good at arithmetic, which I'm not trying to make fun of. I'm just trying to point out. So I'm going to take that 0.25. So I get x equals 0.25 and x equals 3. Okay. So let's figure out how to do this. The binomial with the one for x equals 3 is simple. You just subtract 3 from both sides, you get the binomial. Agree? Got a decimal though. And it's a terminating decimal, meaning it doesn't go on and on and on forever. It doesn't ever repeat. It stops. So then we have to think, okay, 0.25, how can I make 0.25 the same as a fraction? What fraction would go along with 0.25, do you think?
1/4.
How much?
1/4. Oh, 1/4.
1/4. Yeah, 1/4. I thought you said 0.4. I'm like, I'm sorry. So 1/4 is the same thing as 0.25. Now, if you don't know how to get to that, if you're not sure what fraction it would be 25 over 100 is the same thing as 0.25, and then reduce. 25 goes into itself once, 25 goes into 100 4 times. That's basically the math that's taking place. So now I need to say this. I'm going to start getting rid of the fraction. So now I get 4x is equal to 1. And then I realize that 4x, subtract 1. So my two binomials for my answer, my factored version is this and this. And don't you wish you kind of knew that in Algebra 1? Wouldn't that have made it a little bit easier? It's like, well, where's this quadratic formula fit in place? I mean, it's a trick. It's a little game that you play to manipulate to get the answers. But what does the answer mean? You don't know. Okay, so you do the same thing with 4 and 5, but then we get to number 6, and 6 is a whole different ball game. But we have to understand what's taking place with number 6. So can I move off the screen? And let's take a look. Let's focus on what number 6 is. Nope, I don't want to highlight these. Is that 10x squared y to the 4th? Oh, this is a cube? Okay, cool. Thank you. And then minus 25x squared and y to the what? Y to the 5th? Okay. Now, friends, this is ugly. This is ugly. Okay. Can I tickle your brains a little bit?
Of course.
Okay. graphically, I don't think there's anybody in this class that can even fathom what graphically this would look like. Because I certainly can't go y equals that. The reason I can't go y equals that is because I already have y in the equation. Okay, so that's not going to work. Do you want to know what graphically this looks like? This is going to hurt. It's going to hurt your brain. Okay? All right, let's start talking about a dimension. You guys know dimensions, right? Length, width, height, right? Length, width, height, 3-dimension, right? Agree? Well, that's fine for the x's. Length, width, height. That's 3-dimension. Then I have y to the 5th. Y to the 5th is actually something mathematically that exists in the 5th dimension in the y direction. It fits in the 3rd dimension in the x direction. And yes, there are more than 3 dimensions. Okay, if you go to the world of physics, there are 9 identified dimensions that they can fathom. Okay, and I don't know what they all are. A lot of people will say that time might be a dimension. Am I losing you guys over there? You're like, wait a minute, I don't get this dimension stuff. Okay, here's a real simple thing with a dimension. Ready? This is my hand. This is the one I was born with. Agree? This hand is 3 dimensions. Yes? Everyone agree? That's my hand still. You know, it's my hand when you look at the shadow. Agree? That shadow is 2 dimensions. So I took a 3-dimensional object and made it 2 dimensions by looking at the shadow of the 3rd dimension. Okay, ooh, let's get it's kind of weird. So a 3-dimensional object can be represented in 2 space by looking at the shadow of it. Y'all ever, at night in the summer, you're walking down your street, you might have a street light, and your shadow, and standing under a street light is pretty much right below you. And then as you walk away, you step backwards from the light source, your shadow might start growing bigger in a dimension. It gets bigger and bigger and bigger. As you're further away from the light source, that dimension gets longer and longer and longer. So it looks like you're really tall. Your shadow exists, agree? You can see it. That shadow is a 2-dimensional object based on a 3-dimensional model. Your body is a 3-dimensional model. You have a length, width, height. You have volume to your body. Okay. All right, let's get weird. Are our bodies the shadow of a 4th dimension? Am I looking at your 3rd dimension shadow of the 4th dimensional being that exists? Uh-oh. Does that really work? Oh my gosh. It's like, where can we drop this class? You just went heavy. So let's do this. You have all drawn this before, I bet you. Been bored in class. You look over at your neighbor and they're drawing this. Agree? You seen this? Yeah. Okay. You might have drawn it a lot neater than Stirrup Through, but that's kind of fun to draw. Okay, and you might get one, you're looking over at your friend and they're like, oh, I'm going to shade this side over here. This side over here is all blue. And then maybe I can change all the color. Let's pretend I can color really good. And I know some of you with a little OCD are like, color the rest in, would you? No. Okay, so I took a math class a long, long time ago when I was getting my degree. My math professor, his name's Peter Papadopoulos. He was one of the founding fathers of a math called chaos theory. Okay, let me explain to you in terms that you will understand easily what chaos theory is. It's the in-between dimension. So you've all heard the thing, you look at a sheet of paper. That sheet of paper has length and width to it. Technically has a little tiny bit of width. But you say this piece of paper is 2-dimension. It has a length and a width. As I keep stacking more and more pieces of paper on top of that piece of paper, we start getting a height to it. So theoretically, a whole bunch of paper altogether becomes a three-dimensional object. Honestly, that piece of paper is a three-dimensional object with a really thin edge. So what would happen if I were to take this three-dimensional shape? Let's get goofy. Let's go here. Go to here. We're going to make this. We're going to make our box a little neater. Okay, it's okay. I made it a little larger. That's okay. Dimensions still work. So, my friends, once I complete this, is this truly a three-dimensional box, or is it a three-dimensional box represented in two-dimension space? Oops. Let's undo that. I didn't mean to break the seal. Three-dimension? But that flat surface up there is only two-dimensional. It's got a length and a width. So that's basically, if you were to, let's say, take a whole bunch of straws from Sonic or wherever you get your straw from, McDonald's or whatever, and you glued all the edges together, could you make that shape three-dimensionally? And if I were to shine a light source behind it, could I project that shape with a flashlight onto the wall? Right? Make sense? Playing a little math here. Okay, so basically, I have a shape up there that's representing two dimensions. And I'm going to show you something that you're never going to stop unseeing. Okay. Is the littler box back here the front or the back of this object? Does anyone see that this is what seems to be coming out at you? Or do you start seeing that this back box is coming out at you? Stare at it long enough, you can start convincing yourself that the little box could be in front. You seeing it? Kind of weird to look at? Kind of weird to talk about. Okay. So the box is flipping back and forth on, if you see what I was talking about, you can make that smaller box that you think is in back, you can actually make it come forward. If it comes forward, what it appears to be, it appears that this box here is coming out this way, right there. Or you can see that this front box here is coming out this way. Does that make sense? And that's kind of your depth perception. Your brain is playing a game with you. It's starting to flip it back and forth now that I pointed it out. Now you never see that 3D box that you drew on your board in your English class on a piece of paper the same again. Like, uh-oh. All right. Can I show you fourth dimension? All right. So I don't need this. Let me get rid of this little thing. I don't know what that was for. Whoops. There. Delete. Oh. Undo. Oh. Yeah. It's playing games with me. All right. I'm going to highlight this whole thing. I'm going to copy it. I'm going to paste it. I'm going to move this box. Move this box over here. So now I have two identical boxes that are flipping backwards and forwards at each other. All right, 4D, you ready? Let's really mess with people's minds. I'm going to do a green line. Let's attach all the appropriate vertices. It's like, what class did I sign up for? Okay, so what you're basically doing is you're mapping all the appropriate vertices to it. Okay, so this black and green jumble of stuff that right there, my friends, is a fourth dimensional object represented in two-dimensional space. Okay? So let's go for a dimension. What is a dimension? A dimension is something you can go backwards and forwards on. So on our original square, can I go left and right? Does that make sense? That's a dimension. Can I go up and down? That's a dimension. Can I go back to front or front to back? That's a dimension. Can I go diagonally this way, this way? That's a dimension. That's 4D. So what chaos theory is basically going from 2 dimensions to 3 dimensions. I can't just go from 2 to 3. All the decimal amounts of dimensions between 2 to 3 has to exist. All has to exist between 3 and 4. If I duplicate that whole crazy mess and duplicate it down below and attach all the appropriate vertices, that becomes a 5-dimensional object. So there's really, in theory, mathematically, there's an infinite amount of dimensions. And all a dimension is can I see a dimension that's higher than I am right now? No. But I can see a dimension below me. So I can see from 3D to 2D to 1D to no D. No D is an infinitely small dot. See this dot right here in space right here? It's in my finger. It exists. That piece of space exists. That's 0D. My 0D was touched by my 3D. And I went through the second and the first to get to the 0D. So let's take us back to this real ugly looking problem that they wanted us to factor. Oh my gosh. How in the world can we possibly fathom getting through this? Well, our minds, unfortunately, can't do it. So what we basically do is we start doing some parts. And you have to say, okay, what number goes into 5 and also goes into 25? What number goes into 10 and what also goes into 25? I gave you the answer being 5. Okay. So that gives me a 5 outside, gives me some parentheses, and that leaves me a 2 and a 5 and a minus sign so far. Agree? Now let's talk about the x's. I have xxx for the first term, and I have xx for the second term. So what's the maximum number of shared x's between the two? 2. So watch this. Ready? This is xxx, and this is xx being multiplied. So the maximum number I could share between them is 2. So I pull an x squared out front. That leaves a single x behind here, and there's no longer an x that is with the 25x squared. Okay, so with that knowledge, what's the maximum number of y's that's shared between the two? 4. So I got y to the 4th. So there's no y left here because I factored them all out, and there's 1 left here. And this is now our factored version of it. So it becomes a different thought process when dealing with it. If Desmos allowed us to graph in higher dimensions, we'd actually be able to do this problem. Now, the only way that we have figured out how to do these types of problems mathematically is using something called a matrice. Do you remember solving systems of equations? Remember you had like y equals 2x plus 5 and y equals 7x minus 8? And you might use substitution to set them equal to each other to solve for x, and then plug the x back into one of the equations to get the y. Then you could have graphed them, and there's a point of intersection became the solution to the set. Oh man, where do we go with this stuff? We can get crazy with it, and I mean, it should be twisting your head around a little bit, and that's okay because no one's ever talked to you about what's taking place with these problems. But number 6 is kind of a special case of how can we truly factor it. And right now, where we're at is in this class, that's the only way I know how to factor it. As of right now, I can't graphically look at it. Let's get away from that. Let's go to number 8. Number 8. Number 8, does that say x to the 4th? So it's x raised to the 4th minus 1. Some of you might recognize that as something called the difference of two squares. Agree? Which means if you recognize, if you're good at algebra or you had a little higher level math, this technically could be reduced to look like this. Well, hey, see you in a little bit.
Oh, okay.
Well, you can come in here and eat if you want. It's okay. Good to see you. So take a look. I had my red equation here, my blue equation here. What can you tell me about between the red and the blue? They're the same? So this is the factor part. Now some of you might recognize that x squared minus 1 is also the difference of two squares. So this is blue. Okay, so we could factor down a little bit further. X squared minus 1 factors to x plus 1 and x minus 1. Oops. Nope. And then x squared plus 1 actually doesn't factor down nicely unless you were using something called the imaginary numbers. So we're just going to leave it as x squared plus 1. Okay, so what's the difference between the red, the blue, and the green? Are they all the same? Yeah. Okay, so how could you possibly go through this problem at the point that it's at and figure out how could you actually factor it? And here I'm still going to look at where it crosses the x-axis. All three of those exact same equations, just factored versions, are the same, in which I get minus 1 and plus 1 for my x-intercepts. Okay, so basically x to the 4th minus 1 is going to break down where across the x-axis to this. Okay, so these are the two factored parts. And then you kind of have to recognize this is called the difference of two squares, which would then break down to this. And this doesn't really break down in the real number system. And don't even get me started on number systems and why the heck they named them those number systems. Hey, why did I tell you that the Cartesian plane is numbered 1, 2, 3, 4 counterclockwise? Why did I have it?
He's left-handed.
Yeah, Descartes was left-handed. That's the only reason. You go to some really smart mathematician. I'm not a smart mathematician. I just learn how to play the game. You ask them, why is the Cartesian plane labeled counterclockwise? They will give you the most obscure answer in the world, which is incorrect. And it's because Descartes was left-handed. I mean, there's nothing mathematical behind that. It was simpler for a left-handed person to label it that way. That's all it was. And it's just kind of goofy. All right. So, my friends, for this Algebra Review 1, still with me? Yeah. Oh, absolutely. I would like you to complete 1 through 9, in which I have done a great deal of them already, correct? Let's see if you can get a start on that. And it becomes a little bit kind of wild. You might come across one that you're not quite sure why it worked out that way. And that's okay. We can deal with it. So I'm just going to put this little note on my book to remind you. Remind me. So for Wednesday. So I know tomorrow when I come in, we'll make sure we cover those. Anything got too heavy yet? Dimensions are messing with you a little bit too much? It's okay. I'm here to tickle your brain a little bit.
Can I use the restroom when Johnny gets back?
You don't even have to wait, just go. Shove his head in the toilet when you get there.
All right.
Deal?
Gotcha.
Side.